because of this guy, Ed Leedskalnin, I'm hooked on electricity. I'm hooked on static, hooked on magnetism, and I'm also hooked on sound. And the sound part of it is what I brought to the table without knowing about the other stuff. I have a music engineering degree. I used to be a DJ back in the day. So I know a lot about sound. That'll get us into frequencies where I believe Ed Leedskalnin was deeply entrenched in frequencies. We're going to focus over here on the components of Ed's picture here. This is in his workshop. This is his machine, and I believe this is his best machine. If you guys ever get a chance, order yourself one. Magnetic Current by Edward Leedskalnin. The one to the left here came from Coral Castle. Had that for a long time. The better one with the pictures is this one here. You get that online. This one here was given to me back in '87. And this one is really cool, but it's not about magnetic current. It's just a little brochure. Order yourself some, read those. So in a section of his magnetic current, he talks about a lot of experiments that he had. And we're going to pick apart and dissect these components. So right now, we're focusing on the pipe. This, I believe, is a capacitor. Got a change coming over the top of the capacitor. I believe it would be the negative side of the capacitor. And they're all connected, and they come around down bottom and connect to this box. On that box there's a wire tapped in the center. You obviously can see it coming up. And it goes, I believe, to probably the positive side of that capacitor. Then I also believe up on the wall, I'm reaching up to the wall, how Coral Castle is now, everything is up on the wall now, but there's a coil that goes down the pipe. And I'll show you, I made a little demonstration right now on the theories that I'm working on. And also this bar, it's a metal bar, it's about 1.5 inches wide, about 1/4 inch tall, it's probably 3 feet long, maybe 2.5 feet to 3 feet, and it sits in front of this box, and it looks like the magnets approach underneath it and take off. Okay, so on those right there, I have replicated, got the pipe, we got the bar going across the top, I got the voltmeter hooked up to the coil that I have inside, and based on one of Ed Leedskalnin's sections in there about if you want to make a stronger magnet, he says put a iron core in a coil and put it inside of a metal casing and touch one side. Here's the one side. And that's what I believe that we have over here on Ed's section there. And we're going to go ahead and take one of Ed's V-shaped magnets, and you got the voltmeter, and we're just going to go underneath, and we're going to make sure that we are touching. You got to make sure it's touching. So we touching. Let me make sure this pipe is touching. So pull it up just a hair. And then gently close it down. Awesome. All right, so we're going to bring them V-shaped magnets. I'm going to have 2 of them this time. bring it up to the metal bar, and you can see the meter going. And that's from me just wiping across the bar. My magnets are so strong, I just charged these that they're sticking to the metal. So maybe I can come over to the bar here and you can see we can bring up the voltmeter. And even if you come, so my thing here I'm focusing on is when the wheel turns, the magnets go underneath the bar, creating a electrical current coming out of the back of that. Chains are the negative, the wires the positive, charging a capacitor. And on my next video, I'll show you the capacitor charging. So you can see. Magnets so strong they're sticking. So let's come over here. These magnets are not charged too good anymore. I'm beating them down. They barely pick up anything. So we're going to come over here and I set up a little charging station. It's Ed's PMH. Got a lot of turns on both sides here. I got 24 volts coming into them, and we're going to check the magnet, see what side is the south side. Okay, and over here, we're going to come over to the PMH. We'll check that that's the north, that's the south. So on the north side, we want the south side of the magnet. Where's the south? So there's the south, okay, the south. So we're going to put the south like that. Ooh, how am I going to do this? Somehow I got to touch that with the other end of that. I don't think it could be done. Let's see if I can stick this to itself. Alright. I don't know if this is going to work, guys. This would be a first. Usually you use it come in through the front. Yeah, it worked. Look at it now, it's sticking. So, this is how I'm charging these magnets to becoming super strong. You can see how strong this thing, the compass is reacting every time I touch that. So, I want you to see how fast the compass changes when I put this near. You can see the strength of it. See the compass even moving? So watch this. Compass is big time, okay? Big time, like reactive. So let's come back over here to this piece of metal. Couldn't even lift it before. And big time. Got good strength pulled to it. So let's come over here now and bring it near the pipe. And let's see what shows up on the meter. Okay. And let's look down here and let's come across the metal. Keep sticking to the metal. So with the wheel will come real close underneath it. But the tighter you come, where the force is greater, the more shows up on the voltmeter. So when it passes this, it'll have stuff showing up on the meter. So you're coming at it from both ends. With Ed's wheel here, on this front end, he's obviously got power. He's got voltage showing up on both sides here, positive and negative. And you notice that one side's darker than the other. So I would say that's the positive side, the negative side of this rail. Because what's happening is the center of this coil down here is the core, okay? Now the core is connected to the outside casing through this piece here. And we're at the juncture there, I would call it, or at the tap of this magnetic induction. So we're actually going to be pulling off voltage. And the bottom of this is connected to the ground, so we have all the bottom end voltage we could ever need, and we'll get more creative on building the coil. We'll make this coil like Superman. Right now it's just a little spool I have here of some 28 gauge. But we got some good things going on here. Building Ed's wheel. Got frequency um, generator. Got my frequency counter. So those of you who are into seeing if we can get a frequency driven in the coral or anything, to where we could get it to levitate, we can get it to melt or fall apart, whatever frequency we get in there. We're going to play around with frequencies with this whole thing and dig deeper into some of the harmonics. Even taking this coil and sending a frequency down this shaft into the ground and having it feed back and getting the ground's frequency and whatever that is. At least we can go up. I think this is 25 megahertz is the speed we can go up to, and that's plenty fast enough. We'll find the Earth's frequency somehow. We'll tap into the Schumann resonance of the ground. We'll go by hurricane hits average per minute, and we'll break that down, and we'll see what that number is, and we'll frequent. I think that's like 6.7. I think is what they have. 6.7 hertz, and we'll pulse the ground, and we'll see what happens from there, and see if we can start. Ed had also in this book that I liked. He's got this picture of a sound room, and this room that he has that they call the sound room, I believe, is where he would. I think it's that right in there. I believe or behind that. That's his barbecue, and I think it's that one or behind it. It's a sound room, and that's where he would listen to sound, and that's where I bring sound to the table, or Ed's telling me to do it with, with sound, because when you do objects, say if it was coral rock, you were able to do something to manipulate it and take the weight out of it. It's pretty obvious that we're dealing with everything is being pulled down, so we'd have to reverse that side of the charge. So inside the rock, you would have, for instance, you would have a positive energy and a negative energy, and it has its balance, and it would have its nucleus, okay, its center. The center is the proton, the neutron, and the outside is the negative. And you would take that negative force, the negative pressure that's on the outside of the rock, and that's what wants to pull the rock down to the ground, which everything's being pulled into the center. You would oppose that by putting a electromagnetic frequency into it, not electromagnetic pull force, but it's a frequency. And we'll get into these magnets. I bought some pulse resistors, and these are badass son of bitches, and these are 1K, and what I want to get into is resistive and force, because the resistance and force is what everything is, even in space, and the sun being a positive force, the space itself, the dark vast of space, is a negative force. The planet Earth, for instance, because of its outside casing, is mainly glass, 96% glass and 4% inert metals, that's an attractive dielectric. So the way I look at this, and I'm pretty sure the way Ed looked at this, is that the dielectric is our air. On the left side is the Earth, the right side is space. And then with Earth becoming a negative, on the other side of Earth is air again. So there's another dielectric, and then outside is space. So when you compress both sides, you make like a donut, with the center being the connection of the core, and then you have